All right, welcome everyone. I think you can all hear me. Actually, I can hear me now. That's great. What's that?
You're kind of light.
I'm kind of light?
Yeah.
Oh, loud. Loud, light meaning light. All right, he's on that.
All right, give me some banter.
Some banter. All right, so let me see here. Yesterday, it was snowing here in Denver. That's crazy. I left Maine to get away from snow, and it's snowing. So how's that sound? Is that my boring snow story sound okay? All right, great. I could have went on, whoa! Save the echo for when I'm singing. All right, that sounds good?
Can we hear?
Yeah, it's okay.
All right, I'm getting some thumbs up, so that's good. All right, welcome everyone back from lunch. I have the pleasure of having the after lunch session when you are all in a food coma. So that's why we're looking at SQLite, which is not a brand new, exciting, different thing like we had this morning, all kinds of new things to learn about and absorb. This is a little bit familiar. I'll be covering some features that maybe you haven't played with in SQLite. And then after me, you'll have a couple more sessions with some more teasers and cool new stuff. In case you don't know, I am Paul Lefebvre. So a little bit before we start about SQLite. Hopefully most of you have heard of it, but I want to do a little poll of the audience here and ask people how you pronounce this. So those of you that say SQLite, like I've been saying, how many people say that? All right, great, that's a lot of people. All right, what about SQLite? All right, great. Not too many people say SQLite. That's interesting. All right, and then the last one is SQLite. Wow. Well, note, those are the crazy people that are here. All right. That's insane. Anyway, according to Dr. Richard Hipp, the creator of SQLite, on a YouTube video, this is supposedly the correct pronunciation, SQLite. Now, that's great. I respect and admire Dr. Hipp, but I'm not changing the way I say it. So you'll hear me throughout this say SQLite. As you know how it is, it's hard to change how you pronounce things. But apparently, SQLite is the way to say it. The more you know. So SQLite first appeared in 2000 as version 1. And there was a version 2, but we don't really care about that. What we really care about is version 3, which appeared in 2004. That's the version that is still in use today, and that's kind of the one they've committed to at this point. Everything that's updated from that is just dot releases on version 3. And the cool thing about SQLite, of course, is it is public domain and open source, so there's no restrictions on its use. So it is everywhere. It is lightweight and embedded. That's kind of ties into why you see this everywhere. And it is often, I don't know that you can officially track these things, but at this point I think people consider it the most widely deployed database in the world. You see it on, mobile devices, you see it on iPhone, Android, you see it on all computers. It is just everywhere. Of course, SQLite.org. I like to give people web addresses because you're all on your computers. About 1 out of every 8 are paying attention to me, so the rest of you can just go to the website and read some stuff there. In Xojo, what is SQLite? Well, we have 2 classes for SQLite. SQLite Database, which is the one that's used for desktop, web, console projects. That will also probably be the Android class as well. And then iOS SQLite Database that is only used in iOS projects. So a few highlights of some general features of SQLite. Well, it's cross-platform. That was a little appealing to us when it came out. We tend to like cross-platform stuff. So this was great. It runs on Windows, it runs on Mac, it runs on Linux, it runs on Android, it runs on iOS. It runs everywhere, and that is very nice. SQLite is file-based, unlike larger database servers maybe you've used, so you just get a single file you have to deal with. And if you haven't paid close attention, the data types in SQLite are unusual. And I'll get into that a bit more, but this is something that doesn't directly impact you, but it can cause some weird little issues if you were totally unaware that this is the case. SQLite is a relational database. Obviously, it has tables as a feature. Otherwise, that would be a strange database, I suppose, to call itself SQLite. But it's a little restricted on what you can do with tables. For example, you cannot alter a table to modify an existing column. That's the light part. It also has views, but those are also a little bit restricted compared to other databases. Views are always read-only. SQLite does have database transaction support, which is pretty much a requirement to really call yourself an actual database. And I generally recommend that people use some sort of database tool when working with SQLite. There's a bajillion plus one tools available that work great. A SQLite database tool lets you query the database, easily import and export data, see data, write your queries. That's handy for writing and testing a query, and then you can copy and paste the query and stick it in a constant in the Xojo project, and then use it with your SQL execute or select commands, things like that. So definitely find a database tool that you like. Ask your fellow conference goers here which tools they use and like, and give one a try. But going back to the data types, a little bit about what those mean. So SQLite's data types are not static, unlike probably every other database you've ever used if you've worked with other databases, or even Xojo itself, which is primarily static typing. SQLite is not. It has something called storage classes, and only just a few of them. So the classes it has are these here: integer, real, text, and blob. I love blob. That's just a great name. So just those. Whoop. Did my audio go out? Yep, battery went from 3 dots to 0 in 6 minutes and 20 seconds.
Probably why I was getting that fuzz sound too. Probably.
Oh, yeah.
Sorry.
All right, we're back after that brief commercial break. So storage classes, there's only 4 storage classes with SQLite. And these aren't data types, they're storage classes. That's a different term, a different meaning. So the big thing to notice is there's no types for things like Boolean or date time or anything like that. When you create tables, you can type in, start date and give it a date type in SQLite, and SQLite doesn't yell at you, so you're saying, well, Paul, you're crazy. But I'm not crazy most of the time, and there's no date type. You can put whatever you want there, and it'll fall under one of the storage classes. In the case of Boolean, that's typically going to fall back to an integer. Date or date time you can store in different ways, as an integer using seconds from 1970, or as text using SQLite format. So instead, when you are creating your columns, something called a type affinity is used. So kind and gentle, it's an affinity. So this is the recommended type for the column. It's not a required type, which gets into the big points of SQLite's non-static typing. But these are the affinities you can have: text, numeric, integer, real, and blob. But even with an affinity specified, you can stick anything in the column you want. So if you've got a integer column and you decide you want to stick the text Paul in it, SQLite will do so. It will not generate an error. And then if you query that, you'll see 1, 2, 3, 4, and then all of a sudden the text Paul shows up in one of the columns. So that can be a little off-putting for people that have worked with other databases. So it's important to pay attention to. Generally speaking, I don't, if you're used to working with databases and static typing with Xojo and all that good stuff, I certainly do not recommend you go, oh, yes, I am just shoving everything in the column willy-nilly and going to go hog wild. That's probably not the world's greatest pattern for a standard relational database. But this feature is pretty cool if you wanted to use SQLite as something like a storage mechanism for, say, a dictionary. Your dictionary in Xojo is a variant, can contain anything. So you could map that to a SQLite table, and it could still contain whatever you happen to stick in the dictionary. And then you wouldn't need a bunch of more complicated table structure or anything like that. So it does have its uses, I suppose, but it's something to be aware of. And if you happen to get bored at any point during the conference, because there's lots of downtime, you can head over to the data type 3 page and have a little light reading this evening. Lots of stuff there, and you'll notice it's called the data type 3 page because all this stuff is very specific to the version 3 of SQLite, which is the current version that they've kind of committed to for the foreseeable future. So, very quick thing to point out here, you're connecting to SQLite, boom. You just create an instance of the class, and then you point it to a file, and you call the connect method. If you're using a desktop project, it is perfectly okay to just connect once at the start of your app, and then just use that connection reference throughout your app. If you're using a web project, typically speaking, you're going to want to do connections per session rather than global to the app, so you can maintain transactions and just overall have better performance. So what are some of the superhero features that I want to point out to you guys today? I want to just list them here, and then we'll go through each of them and maybe take a look at a project. So first is write-ahead logging, WAL. And then we've got in-memory database, triggers, the pragma statement, foreign keys, full-text searching, indexing, and Blob. I love Blob. So write-ahead logging. What is write-ahead logging? That is a different way that SQLite stores the data in the file. And it can be faster for most scenarios. So the normal way that SQLite saves data to a file is it actually writes the data twice. It writes it to the actual database file itself, and then it writes it to a rollback file. That's 2 disk writes. That's obviously twice as slow as 1. So that has its value if you don't, but people don't often roll back a lot, so that's a little bit unnecessary maybe at times. So WAL kind of flips that, and instead it writes your change once, and it writes it to a WAL file that exists alongside the SQLite database file. So this is just a single write to the disk. That is obviously faster. Now it does have downsides. That means queries are going to have to check in a couple places for data instead of just one, essentially. But it can be very fast, and it is particularly useful for people that use SQLite with a web app because you're going to want to have those writes happen really quickly because when you're writing, the database is logged. So you flip on the while setting, and your writes happen more quickly, and your database or your web app becomes more responsive. So I did write a section on the user guide on this. It has some specifics, and of course, if you're into super long details, you can go to the SQLite page. But to turn on the WAL setting, there's 2 ways. Xojo has a property which is called multi-user, pretty much in deference to the web app settings, because you want to turn this on because your web app is going to have multiple people connecting to it, and it makes SQLite more responsive. You can also turn it on with a pragma if you're into cool, nerdy pragmas. In-memory database is really simple. It's just a SQLite database that does not have a corresponding file, so everything is stored in memory. That's not a good long-term plan for important data, obviously, but it can be really handy to have temporary high-speed data lookup. You can, when your app starts, you can load things up into an in-memory SQLite database and then query it as your app is running to find things more quickly, because you get to that point take advantage of SQL itself, which can be a great way to look up information. And you can use the attach feature in SQLite to connect a file-based database to an in-memory database and then write SQL statements to copy data out of the in-memory database back to a file should you actually need to retain it. But when I've used this, it's primarily been for caching type purposes. And the syntax, again, is very simple. You just create a new instance, and then you connect to it. You just ignore the file part. And then you can use it just like you would a normal SQLite database. Triggers. Most databases have triggers. Triggers are SQL code that runs when table data is modified. And this would be on inserts or updates or deletes. And this is useful for a variety of things. You can use it for logging, particularly handy thing. Anytime the table is modified, you can write something out into a logging table that says what was modified, when it was modified, that sort of thing. And because it's at the database level, it'll happen no matter which client or app is connecting to it. So you don't have to have code in your desktop app and your web app if they're sharing the same SQLite database. It just happens on the database level. You can also use it to update related information. So if a particular column gets updated in one table, you can have a trigger update something in a totally different table, or even the same table. The syntax for that is on the create trigger page at the SQLite website. And the syntax for that isn't too bad. You just call the create trigger command, and typically you're going to have an after trigger. This one here runs after an insert on a particular table, and it updates the table itself. It updates another column that is a concatenation of two columns that are on the new insert. So this combines a city and a name and updates that column for you. So this essentially is kind of like a computed column on a SQLite table. The pragma statement changes how SQLite works. When you connect to it, it has a bunch of defaults that it operates in, and most people just go with those and use them as is, but you can tweak some of them. And there's quite a bit on the SQLite page you can read through. I'm going to guess there's like 30 or so that you can play around with. Two in particular that I like are user version and the foreign key one, which I'll talk about in a moment. The user version one is neat because it lets you set a version of the database itself. And it doesn't serve any purpose. It's just a value that you get to set in the database. And I think by default it's probably 0. But what you can do is for your apps, as your app is updated over time, you probably have update scripts that are altering the schema, maybe modifying a table or adding new tables or something like that. And when you do that, you can up the user version of your database. And this allows your app to check what version of the database it's running against to make sure it's compatible. So if you have a desktop app that starts up, it can check to see which version of the SQLite database it's connecting to. And if it says, I'm connecting to version 3, but I want version 4, it can then dig out the scripts to upgrade it to version 4. So it's a great way to make sure that your stuff stays synchronized just by setting a little value on that table. And because it's part of the database, you don't have it embedded in an app or something, and it always stays where it belongs.
How do you read that?
I'm sorry, Bob?
How do you read it?
How do you read it? Oh, you do the same thing. You leave off the assignment. So how do you read the pragma for user version? You just do pragma user version as a SQL select command, and it's returned in the record set. All right, and foreign keys, which we'll talk about momentarily, can also be enabled using a pragma. Speaking of which, foreign keys is when you're relating two tables. This requires related keys to match keys in other tables. Now, you can obviously set up a database to do that. You can have a team table that has team IDs and then a player table that has a reference back to which team they belong to. That's great. But SQLite by default does not enforce any of that. So if I added a player and gave him a team ID of a team that didn't exist, SQLite wouldn't care. It would just insert that data in the table for you and go on its merry way. And then you kind of have a situation where your data is totally invalid. You've got a player that does not belong to any team, and that typically does not make much sense. A little bit more information at that site there. So when you create a table, you can assign the foreign key. So if you look at the very bottom of the player section here, you can see that it has specified that the foreign key team ID on the player table is referencing the ID column on the team table. So that's how you define the foreign key. But they're not enabled by default, as I said. So you have to use the pragma to enable the foreign keys each time you connect to the database. And there are a couple other related pragmas that you can use to check overall integrity or even display the foreign keys that are assigned on the database. So the big one is the very first one. You have to say foreign keys equals on, and that turns on the foreign key support. And that's where you'll actually get a database error if you try to create data that's invalid based on your database structure. And there's a few other pragmas here that you can run to just check integrity of the foreign keys or check or list them out for a table. Full text searching. Now, if you have tables that have text, often people want to search that text. The fallback that people often use is just to use a select and then in the where use the like command, maybe with some wildcards or something like that. And that works great, but it can be pretty slow. That's going to do a full, what's called a full table scan, so it's going to go through your table line by line and just look for stuff. And that quickly gets inefficient. So full text searching provides a better way to do that with just some smarter matching of text and other features. Starting with Xojo 2016 Release 3, we upgraded to a version of SQLite that includes the version 5 of full text searching, FTS 5. That's probably the best one to use now. It still also includes FTS 4 if you needed it for backwards compatibility, but FTS 5 has some cool new features, including the ability to add display a ranking of your search results. So you can order the results based on what is the most likely match. And another cool thing is you can actually highlight this section of the text where it thinks the match is, which is pretty cool. We have an article like that, about that on the documentation. To do this, you create what's called a virtual table in your SQLite database, and you tell it you're using the FTS5 full text search engine, and you give it the columns you want, and then you copy into it some data from elsewhere. This isn't, because this is a full text searching table, you actually got to populate it with data. It's not going to be your primary data store. And then you can select from it. And you can see the select statement here has a little bit different syntax with the match command. And then you can order it by the rank. And then you can also use the highlight function to use some special characters to highlight some stuff in there. We'll look at an actual example that shows what that looks like in a moment. Yes, Kim?
Just curious, the match command, is that actually using a regular expression or is that just plain text?
The question is the match command using regular expression or is it plain text? Of course, Kim would ask that. I don't know, actually, if it's using regular expressions because every time I read a sentence that has the word regular expression in it, I tend to skip it. I can look that up, though. And then I will bug you on how to write one and test with it. Indexing, of course, is available on just about every database in SQLite. It improves performance when you're looking for data in the tables. So you're going to index the columns, or even groups of columns, that are used in where clauses when you're trying to retrieve data from the database. And if you've never used indexing before, people's initial inclination is to just, oh, I use this table a lot, I'm going to index all the columns just in case I need to look up on them. And don't do that. You do not want to over-index a table. First of all, it's going to make your database larger. I mean, all that data has to be stored somewhere. It's going to be put in the SQLite file. So that's one problem. That's a lot of overhead, a lot of extra data that you have to store. But it also could actually give you the opposite effect and slow down your app, because when you insert data into the table, that indexing stuff has to be generated and added to the database so that it can be used later. So if you're doing a lot of inserts and you've got a lot of indexing, all of a sudden you may find that your table inserts are taking longer than they did before. So you have to be judicious about this and pick the columns that make the most sense. Yeah. I forgot to hit when I was talking those two. Creating an index has very simple SQL. You just tell it the table and then the one or more columns that want to be part of the index. And we get to Blob, which stands for binary large object. And again, you want to consider the appropriate usage of Blob. Remember, SQLite database is a file. So if you have large objects, often which already are files, and then you insert them into a file, that may or may not be the best approach for your database. The SQLite docs actually say that putting blobs that are 50K or less directly in the SQLite database has better performance than if you were attempting to refer to files outside of the SQLite database. But if you're going over 50K, then you have the benefit of using a blog because everything's self-contained in the SQLite database file, but you get the downside that performance might suffer when you try to extract that blob out of the SQLite database. So again, that's a balance of what makes the most sense for your app and how you want to structure things for performance and overall benefits. In Xojo, you can use the SQLite blob class to incrementally read or write blob data, which is nice. That keeps your app responsive. Should you decide to put really large things into blobs, you can read them out incrementally and then save them to files or get them from files. And you can find more information about blobs on the documentation. And now let's switch over to Xojo and take a look at a couple projects that show some of these features in action. So here I have my SQLite in-memory project. This is the best demo ever because I just had to remove code. But you can see here, simple line of code to create the new database, and then I immediately connect to it. And then the rest of the code is all going to run. It doesn't really do anything differently than a standard SQL database. So I can just create the in-memory database, I can create a table on it, I can add some data, I can pull it back. All that is happening in memory. There was never a database file created anywhere at any time. And then if I quit the app, bye-bye database, it was in memory, and that memory's all been released. So using an in-memory database is super easy. And I like to keep pointing that out to people because it's totally not really obvious that doing this is what you get as a result, that it's an in-memory database. It almost looks like a mistake to some people. I created a database, but I did not point it to a file. But you actually get this cool feature when you do that. All right, this is the same. Oh, yes, Bob. Bob is asking, after he creates the in-memory database, can you write it out? You can write it out. SQLite has a command called attach, and you can attach a file-based database to it, and then just select from the in-memory table into a file table. All right, the foreign key example here, I'm just going to run this first. So I think it'll show the error, if I remember. So I'll create the database, I'll create the tables, I'll add some sample data, and then you can see here I got the database error, foreign key constraint failed. And that's because on this database I actually enabled the foreign key constraint, and we can see where that is. And that is, so right in here is where I'm adding rows to the table, and you can see the first three, it's adding it here, but down here I created an intentional error. And I set the team ID to 99. Now, there was only 3 teams that were in this little rinky-dink example, and none of them have an ID of 99. So I attempted to add a player, me, because I like playing baseball, to non-existent team 99. I got an error. That's the database helping me here and saying, hey, you can't add someone to a team that doesn't exist. Now, if I turned off the foreign key enabling using if I essentially did not turn on the foreign key because it's off by default, this insert would have happened just fine. SQLite would have inserted it. I would have ended up with a Paul row in the player table that pointed to a team that didn't exist. That's kind of, that's data that's just floating out there at that point. You may not even have a way in your app to retrieve it or pull it out. So that's a data integrity problem. You don't want that. So turning on foreign key support is a great thing to do if you have designed your database to take advantage of it. All right, trigger. Here, this one looks a little different than the other one. You might at first glance not notice, but there's a column here on the end that says full name. And it has a combination of the city and then the team name after it. So here I have the Houston Crows, so I could click edit on this one and I can change this to change it to the Rockies. And you'll see it updated here. Now this fourth column here, this is not a column on the database. Actually, it is a column on the database, but I'm not inserting it in that way. Missed a step there. But anyway, that is actually filled in by the trigger. So you can see when I create the tables, I have some code right here that's adding two triggers. And they're just SQL statements that are calling a constant that has the code for the two triggers. So if we look at, say, the code for the update trigger, unfortunately this will be pretty tiny. How tiny? Yeah, pretty tiny. You can see that it says it's creating an update trigger, and after an update of either the city or the name column on the team table, it's going to update the full name column to be the city, essentially plus the name with a space in the middle. So I don't have to have app code that updates that column. So this is essentially kind of giving me a computed column, and I don't have to worry about client-side app code dealing with it on the desktop or the web or anything like that. It's just the database is going to handle it automatically for me anytime I touch the city or the name column. All right, and this is an example of full text searching. So I have here a very small database again that just has a table created with a few rows in it. But I searched for a particular word, and it returned back the two rows in the table that have that word. And the neat thing here is you can see where it found it in there. So if I look over here, you can see maybe the word no, that's the word I was searching for, is surrounded in brackets. So squint really hard.
Can you zoom in?
Apparently not. Sorry. And you can see over here it also says no and it's surrounded by brackets. So that's a little bit more useful than using a like just on that part, because you now have the section of the text where it matched kind of shown to you. And what does that actually look like? You can see different parts here. This is the select statement that is querying the database, and I'm using the highlight function, this highlight SQLite function, telling it to hit the test database that I have containing the data, and I'm telling it what the characters are to wrap around the text that it matched, and I just use brackets here. And then I do have it ordered by rank, even though I didn't show the rank. And then you call, once you set up your SQL statement like this, you call it like you normally would, and then iterate through the results to display them. And the setup is set up here, again, using the virtual table. Here I just set it up with a single column, so I went with the SQLite default of content, and then I just added a bunch of text that I could search on. So again, super easy to add to existing SQLite databases you have that maybe need some searching. You can add this virtual table, use a select statement to copy in data from another table that you actually want to search on, and then search on it using this method. You give your users the ability to query through textual data faster and easier with some nice results, and it's just an add-on to an existing SQLite database, so pretty slick. Yes, Kim?
Paul, is that virtual table, is that self-updating, or do you have to use the update yourself?
It is not self-updating. Sorry, the question was, is the virtual table automatically going to update, or do you have to keep it updated yourself? And you do have to keep putting the data in it yourself. It's not connected to anything directly. You need to have a process. You could maybe have a trigger that would populate it when the corresponding table changes.
Is there a reference from the virtual table to the real table?
The question was, is there a reference between the virtual table and the real table? No, there's no reference. They're just,
It's like a standalone table.
it's a totally independent thing that you just fill with the textual data you want to store. All right, and last example I want to show you here is the Blob example. And this here has a SQLite database that just lets you choose files that will get added to the database. And let's pick a picture. Pictures are a common thing people want to store in a database. So you can see this picture here is about 100K. And it's now in the SQLite database, so I don't need the external file any longer. It could be removed. It doesn't need to be retained. There are benefits to this. If you have a web app and someone's uploading the file, you might want to just take the file and stick it directly in the database. Once it's in the database, you can also get it out, though. You can just export it. And let's see if I can put it on the desktop. And then the file ends up right there. It's just a binary stream that creates the file using the data that was inserted into the database. So it's pretty easy to work with. That just is using code right here to create a blob of the particular length using the file, and then the file contents is read using a binary stream, and then written out to the blob. And then you just close everything up, and then that file is now directly in the database, permanently saved. So like I mentioned before, though, you want to be careful with what you stick in there. You're not going to want to stick, gigantic, huge megabytes or gigabytes of stuff into your SQLite database that will just needlessly bloat it and probably cause other problems. And I couldn't have a superhero SQLite database without directing you all to a database of superheroes. So this is available on GitHub, and it has all the superheroes just in time for you to research before Avengers Infinity War opens on Friday. No, I do not work for Marvel, but this was a lot of fun. Apparently there are a lot more superheroes than I was aware of. Who knew? Questions? Yes?
If you have two apps running on two different desktops and you reference the same database file, do they conflict with each other?
So the question is, if you have two different, say, desktop apps referring to the same SQLite file, would they conflict with each other? I'm going to go with most definitely. That's not generally a good thing to do. SQLite does not like having multiple apps connecting to it. It works great with web apps because even though you have multiple users connecting to the web app, you have a single web app connecting to the database. So that hasn't violated SQLite's rule of one app connecting to it. But when you have two different apps connecting to SQLite, you run into locking issues and file system locking issues and a very high probability of corruption. They have several pages on the SQLite website that kind of state it might work, but they really discourage it. So, and related to that is, putting it on, you see people try to put the SQLite database, say, on a network filing system or something like that. That's almost always ends up in tears. Yes, Chuck?
The question I have is about triggers. If you put a trigger in place and you have records already existing, is there a way to invoke the trigger on the existing records?
All right, so Steve's question is, if you have a table with data already in it, and then after the fact add a trigger to it that maybe would modify or update something else, is there a way to trigger the trigger, so to speak? I don't believe so. But Norman in the back is telling me yes, there is, which is what I was going to say next. So,
Update any field on that record, like set its ID to the ID that already.
all right, so yeah, I hear what Norman's saying there. You essentially have to do something that's going to trigger the trigger, so an update or something along there. Maybe you could even update it to itself, but something like that would force it to run. Yeah. I was thinking there was a cool, update all triggers command, but you can manually do it, it looks like. Chuck, you had a question?
Yeah, so you talked about using an in-memory database for lookup tables, basically. If I have like a few hundred key value pairs, would I be better off doing that, or would I be better off doing a dictionary, assuming the keys are unique?
Right. So the question Chuck has is, using an in-memory database that has, say, key value pairs very similar to a dictionary, would it be better to set up an in-memory SQLite database or stick with the dictionary? And I'm going to say it depends how you're looking stuff up. With the in-memory database, you have the power of SQL behind you. So if you do need to,
I'm usually looking for a specific key.
if you're looking for a specific key and just one thing, I would think a dictionary is going to be more lightweight and faster for you there. Yeah.
Just checking.
Yeah. Okay. Yes, in the back.
If you put a SQLite in-memory database in a web app, can you have it open specifically for one session? Can you have multiple in-memory databases for each session?
So the question is, in a web app, can you have multiple in-memory databases for each session? Yes. They're independent instances and totally separate from each other, so that would work fine.
Just open it in the session.
Right. How you would do that is you create the in-memory database in the session when the session starts up, as opposed to at the app level.
That solves a problem with MySQL where you can't have too many temp databases open at the same time. You can only have one, I think.
All right. Well, he's doing some complaining about MySQL, and we don't allow that here.
Now, SQLite was going to fix a problem in MySQL.
Well, that's good.
Is that a super hero thing?
All right. We'll commensurate later about MySQL complaints. Yes.
So if I have a SQLite file in the iOS or maybe like iPad, can I use multiple apps to access them?
So the question is, on an iPad, if you have a SQLite database file sitting on there, can multiple apps access it? No, definitely not. First of all, that file is going to be sandboxed to that particular app on the iPad, so nothing else would be able to touch it. But it also would have the same restrictions that multiple apps touching it, and certainly at the same time is a big no-no. Separately, that could be possible, but iOS itself won't allow that. Yes, Steve again.
I have a simpler question about the trigger one, but you have the means, there is the means SQLite, allows you to save the MRAM database to disk. Is there a similar thing to quickly load those?
Okay, so Steve's question is again back to in-memory databases. You can take an in-memory database and save it back to disk. Is there a way to take data from the disk and load it into the in-memory database? And yes, absolutely. You use the same technique of the attach command. You would attach a file-based SQLite database to the in-memory one, select from the file one, insert into your table in the in-memory one, and that'll copy the data out of the file into the memory. But you have to constantly do the thing. Yeah, I think, I haven't played around with this, and maybe catch William after, but it might be possible to use the backup command that's in SQLite to back up an in-memory database to a file, but that's the opposite of what you want.
Well, see, now I was under the impression that that's what you meant by your earlier answer. If you had an in-memory database and you simply attached a file, that it would put the whole blood into the file for you.
Yeah, no, when you do the attach, you have to do the select and copy.
Okay.
Yeah. Question over here.
If you're using write-ahead logging, is it something you can turn on and off dynamically? So if you start off with a file, turn on write-ahead logging, because generally at that point it becomes multiple files because you've got a journal file and a database file. Can you then turn it off so it becomes one file again? Does that make any sense?
I'm not sure that made sense to me.
Please repeat the
Yeah, I don't think I could repeat the question.
If you start off with a database file and you turn on write-ahead logging,
Yes.
quite often it can become like two files because you end up with a journal file as well as the actual database file. Can you then turn off write-ahead logging during the runtime of your application, and will it become back to being a single?
All right, so the question is related to write-ahead logging, and when you enable that, you end up with essentially a couple files with side by side that are your SQLite database, and can you turn that back off to go back to a single file? Well, first of all, when you close all your commits and stuff, and I think even when you close the database, SQLite does do some cleanup to try and wrap up that extra file back into the main one, so it doesn't always stick around. But you certainly can turn the write-ahead logging off again if you wanted, and SQLite, when I've done my testing anyway, seems to just put it back to the journal mode with the single file. All right, I think we're about out of time, so and we're about out of questions, so thank you all.